Hey there, this is Mr. Alexander, and today I want to talk to you about surface area and volume of 3D solids. So today the formula chart is going to be your best friend because, as you can see, there's lots of different formulas for surface area and volume. The trick's going to be figuring out which one's appropriate in which situation. So I'm going to start with question 2 here because this is a kind of a weird surface area question. And what it says is, calculate the surface area of these solids. And in part A, hopefully you can see that it's the curved surface of the cone plus the curved surface of the cylinder plus the base, one base of the cylinder, not both of them. So to figure out, for instance, the area of the curved surface of a cone, it's just pi times radius times the slant height. So if I'm looking at this cone, the curved surface, the part that I'm interested in, is going to be pi times the radius of that cone, which we can see down here is 2, times the slant height of that cone, which is 5. So that's the first part of my surface area. The second part is going to be the curved surface of the cylinder, and the curved surface of the cylinder is 2 pi rh, where r is the radius and h is the height. So 2 times pi times the radius is still 2 times the height is 6. And then of course the base of the cylinder is just a circle, so that's just pi r squared. And the radius is still 2, pi times 2 squared. So up here I've got 10 pi, and then I've got 1224 pi, and then I've got 4 pi. When you add all of those together, you end up with, let's see, 10, 34, 38 pi, and that'll be centimeters squared. Now if you were going to round that to 3 significant figures, it'd be 119 centimeters squared. Alright, let's, that was just one of those. Let me take another one that's kind of weird down here. So down here we have a hemisphere or a semi-sphere, depending on how you like, whatever you like to call it. In letter C, to find the surface area of that thing, you can see we have the surface area of a sphere is pi r squared. But we only have half a sphere, just the half part of it. But then we also have the base of this thing, which is a circle. So I'd have to do pi r squared for that one. So the only thing I really need to know about that sphere is the radius. And the radius is half of 3, which is 1.5. So I would do 4 times pi times 1.5 squared, and I just want half of that because I've just got half the sphere, plus pi times 1.5 squared. So if I do 1.5 squared on my calculator, I get 2.25. 2.25 times 4 is 9, half of 9 is 4.5. So this whole first part is 4.5 pi plus 2.25 pi. And then when you add those together, that all equals 6.75 pi. And that's going to be in centimeters squared. Now if you want to round that to 3 significant figures, you're looking at 21.2 centimeters squared. So that's surface area. I want to skip. We're going to do some volume, but I'd like to look. I've got three IB problems here actually, and I'd like to do as many of those as I can. So I've got a pyramid here, and it's got a square base. It's made of solid stone, and the sides are 230 meters long. The vertex of the pyramid is perpendicular to the base here, which is O. M is the midpoint, and ABV, this angle here, is 58.3 degrees. So I'm just going to put that on my 58.3 degrees. Show that the length VM, which is this right there, show that that length is 186 meters, correct to 3 significant figures. Well, to do that, I would personally try and redraw this as a right triangle. So I'm just going to do that right here. And I've got an M, I've got a V, I've got a B, and I know this angle right here is 58.3 degrees. And this is a right triangle. From M to B, that is half of 230. So we'll call that 115. So if I'm trying to find VM, I'll call that X. From this angle, 58.3, the X is the opposite side, and the 115 is the adjacent side. So I can set up my sine, cosine, tangent. I can say the tangent of 58.3 degrees equals X over 115. So then X has to be 115 times the tangent of 58.3 degrees. And that is just simply calculator work. Make sure you're in degrees mode first. Always in degrees mode. Tangent of 58.3 times 115 is 186.2, which 186 meters to 3 significant figures. Calculate the height of the pyramid VO. Well, now that I know VM, I can make another right triangle here, and that right triangle I'm going to make is MVO. And I'm trying to find VO, which is X, and I know 2 of the sides of this thing. VM now I know is 186, and MO, we said in the previous problem, is 115. So this is simply Pythagorean theorem. To find the length VO, all you have to do is take the square root of 186 minus, or 186 squared minus, since 186 is the hypotenuse, you want to subtract off 115 squared. And when you do that, you end up with 146 meters to 3 significant figures. With all this information, I can find the volume of the pyramid. The volume of the pyramid, let's see, volume of a pyramid, 1/3 capital A times H, where capital A is the area of the base, H is the vertical height. So the important thing here is that this thing has a square base. So if I'm doing volume equals 1/3 A times H, the area of the base, since it's squared, is just 230 times 230. Or you could do that as 230 squared. It's the same thing. Times the height, which I just calculated in the previous problem, is 146 meters. And at this point, it's just calculator work. Let's see here. Parentheses 1/3 times 230 times 230 times the 146. You end up with, that's pretty big, let's see, 2,556,667 meters cubed, because it's volume. So if you're going to round that to 3 significant figures, you would do 2,500,000 and 700 meters cubed, like that. Okay. So it's big number. Lots of volume in there. And going back to the beginning of the year, write down your answer in the form of a times 10 to the k power, where a is a number between 1 and 10, an integer between 1 and 10. So that's simply 2.57 times 10 to the, let's see, 1, 2, 3, 4, 5, 6th power meters cubed. Okay, we're almost to the bottom of this. This is obviously a paper 2 question, that's why it's got so many parts to it. Ahmad is a tour guide at the Great Pyramid of Giza. He claims the amount of stone used to build the pyramid could build a wall 5 meters high and 1 meter wide, stretching from Paris to Amsterdam, which are 430 kilometers apart. Determine whether Ahmad's claim is correct. Give a reason. Well, if I was to calculate the volume of the wall, let's see, the volume of the wall would just be the volume of a prism, so it would just be length times width times height. In this case, the length is 430 kilometers, which is 430, multiply that by 100 to get 430,000 meters, because this is in meters, this is in meters, so we got to convert it to meters. So that's 430,000 meters times 5 meters times 1 meter wide, and that's about 2,150,000 meters cubed. That's the volume of the wall, which is significantly less than the volume of the Pyramid of Giza. So, since 2.15 million meters cubed is less than the volume of Pyramid of Giza, Ahmad is correct. You could fit that whole wall inside the Pyramid of Giza there. The whole volume of the wall. And still there's more. We're almost done with this problem now. Ahmad and his friends like to sit in the pyramid's shadow, ABW, to cool down. At mid-afternoon, BW is 160 meters, and the angle ABW, this angle right here, is 15 degrees. Calculate the length of AW at mid-afternoon. Since this is 230 meters right here, what we have here, the 15 degrees, is an included angle, and so we'd have to use the cosine rule to figure that out. And the cosine rule from the formula chart is right here, where B and C are your included sides, or the sides you know, and A is the included angle. So I would do 160 meters squared. And the reason I can't just use trigonometry, like right triangle trigonometry, is because neither of these are right angles. I think that should be pretty clear. So you got to use the cosine rule or the sine rule. 230 meters squared minus 2 times 160 times 230 times the cosine of 15 degrees. Make sure you are in degrees mode when you type that in, and you'll get about 861 meters to 3 significant figures. Part 2 says calculate the area of the shadow, and that's the similar formula. The area of a triangle, when you have an included angle, is 1/2 AB sine, where AB are the sides you know, and C is the included angle. It's 230 times 160 sine of 15 degrees, so don't make the mistake of doing cosine there, it's sine, and that, when you type it in, is 4,760 meters squared to 3 significant figures. Alright, that's all the time we have for today. Thanks for watching. We'll see you next time.